Okay, take just a second and look around you right now. The device you're watching this explainer on, the clothes on your back, the chair you're sitting in. How did all of this actually get made? And maybe more importantly, why were they made exactly where they were made? Today, we're going to unpack the invisible global forces and the literally fascinating geographic decisions that bring all our everyday objects into existence. Because, it all begins with a pretty simple truth. Raw materials on their own, they're usually kind of useless to us. A cotton boll straight off the plant really doesn't do you much good. Unrefined iron ores straight from a mine, I mean, you can't do much with a giant pile of reddish dirt. But through secondary activities, stuff like manufacturing, processing, and construction, we transform those totally unusable raw materials into incredibly valuable products. That cotton becomes yarn, and then boom, your favorite t-shirt. That dirt gets converted into steel to build giant machines. We are literally adding value to nature to ensure our own survival and comfort. So, welcome to The Explainer. Today, we're diving into a massive geographic detective story, the dynamics of secondary activities and the global manufacturing industry. Here's the roadmap for today. We'll hit the value of making things, inside modern manufacturing, the location equation, categorizing global industries, and finally, the high-tech landscape. Let's get right into it. Section 1. The value of making things. The word manufacturing literally translates to make by hand. And for a massive chunk of human history, that was entirely accurate. But today, the definition has fundamentally shifted to include goods made by machines. We've gone from these primitive, made-to-order handcrafted items to a highly engineered system defined by immense power and mass production. Moving to Section 2, inside modern manufacturing. So what does this look like up close? First off, specialization of skills. Instead of one craftsman painstakingly building an entire car from scratch, mass production relies on workers repeatedly performing a single, highly specialized task to pump out standardized parts. Then you've got mechanization, basically using complex gadgets to actually accomplish those tasks. We also see intense technological innovation, massive research and development happening constantly to eliminate waste and combat pollution. And finally, a really complex organizational structure. I mean, these aren't your typical mom-and-pop shops. They require vast capital, massive executive bureaucracy, and a huge division of labor. To put that scale into perspective, 2.5 square kilometers of the American Corn Belt might employ, maybe 10 to 20 workers? But that exact same amount of land could hold several large integrated factories employing thousands upon thousands of people. And the ultimate stage of all this mechanization is automation. We're well past just using gadgets to help out human muscles. We are building automatic factories with closed-loop computer control systems. We're literally developing machines that think without any human aid during the manufacturing process. It's an absolutely fascinating transition from human labor to thinking machines. Which brings us to Section 3, the location equation. Because, look, profit maximization is the name of the game here. Industries maximize profits by minimizing production costs, making this a highly calculated geographic puzzle. For example, if your raw material is super heavy, weight-losing iron ore, you locate right next to the mine to save on transport costs. But what if you're dealing with perishable goods like milk? Well, then you build your factory right near the dairy farm. Refining aluminum, that requires massive, massive power, so you're going to hunt for a hydroelectric dam or a major petroleum source. And if you simply need a huge market with high purchasing power, you're planting your flag near developed regions like Western Europe or North America. It's a huge strategic game. But here's the thing. Factories don't just hunt for raw materials or cheap power. They actually hunt for each other. This is called agglomeration economies. Is this wild phenomenon where completely different industries cluster together near a major leader industry. Why do they do that? Well, because they can share transportation networks, tap into the same skilled labor pools, and rely on each other's linkages to save a ton of money. They basically form this massive, interconnected industrial ecosystem. Now, of course, there are exceptions to these rigid rules, and they are known as footloose industries. These guys aren't tied down to a specific coal mine or a particular forest. They largely assemble lightweight component parts that can be shipped from anywhere to anywhere. They produce in smaller quantities, they generally aren't polluting, and really, their main requirement is just good accessibility to a road network. Because they are so flexible, they are quite literally footloose, no strings attached, and can pop up almost anywhere. All right, Section 4, categorizing global industries. One really common way to sort all this out is by size and scale. On the low end, you've got household or cottage manufacturing. This is the absolute smallest unit. Artisans using local materials and simple tools right in their homes to make everyday goods like pottery or mats, usually just for local barter. Step up a level and we hit small-scale manufacturing. This moves production out of the home and into a workshop, using simple power-driven machines and semi-skilled labor. This level is absolutely vital for providing local employment in a lot of developing nations. And then finally, large-scale manufacturing. That's your massive assembly line production requiring huge capital, enormous energy inputs, and highly specialized workers. Factories are also hungry for very different inputs. Agro-based industries devour farm goods, processing them into food, sugar, or textiles. Mineral-based industries chew through ferrous metallic minerals like iron or non-metallic ones like cement. Chemical plants rely super heavily on petroleum to make petrochemicals and plastics. Forest-based industries need timber and bamboo for furniture and paper. And of course, animal-based industries require inputs like leather and wool. But perhaps the most elegant way to categorize them is by looking at the supply chain. Take a look at step 1. The iron and steel industry is what we call a basic industry because its end product, steel, is actually used as a raw material for other factories. So that steel goes to step 2, where it's used to build heavy machines for a textile factory. Finally, in step 3, that textile factory uses those machines to produce clothes. The clothes are the consumer goods, the non-basic products consumed directly by you and me. So essentially, every single basic industry exists to eventually serve a consumer industry down the line. And that leads us to section 5, the high-tech landscape. You know, when we hear the word factory, I think a lot of us still picture traditional manufacturing, grimy, massive assembly structures filled with blue-collar workers. But the high-tech industry is an entirely different beast. It is completely defined by the application of intensive research and development. It's driven by white-collar professionals who, crazy enough, actually outnumber the production workers on the floor. We're talking about advanced robotics on the assembly line, computer-aided design, and this constant rapid-fire development of new chemical and pharmaceutical products. Our sources paint a really vivid picture of this shift. They note that neatly spaced, low, modern, dispersed office plant lab buildings, rather than massive assembly structures, factories, and storage areas, mark the high-tech industrial landscape. So instead of a towering, smoke-belching factory, you have these beautifully planned business parks. And when these high-tech industries become regionally concentrated, self-sustained, and highly specialized, they form what we call a technopoly. Think of the famous Silicon Valley near San Francisco. But before we wrap up, I want to leave you with a staggering statistic to put all of this global scale into perspective. 10%. Despite how much these industries shape our daily lives, major concentrations of modern manufacturing cover less than 10% of the world's land area. That is an incredibly uneven geographic distribution. Yet, the nations that hold that tiny, tiny percentage of industrialized land have become the absolute centers of global economic and political power. It's a real game changer when you think about it. So having decoded the hidden logic behind exactly where things are made, from the heaviest steel mills to the sleekest high-tech parks, I want you to look around your own region with fresh eyes. Consider the business parks or industrial zones in your own area. Based on what we've covered today, are some technopolies developing near you? Keep an eye out because the geography of manufacturing is constantly shifting. Thanks so much for joining me on this explainer, and I will see you next time.